Welcome to the lesson on special right triangles. Specifically, we're going to talk about 45, 45, 90 special triangles. Please don't be scared and run away right now like this guy. I promise this is to make your life easier. It's even in the name. The word special is in this because there's special cases where you don't have to do that much work, as long as you know the shortcuts. That's what we're going to talk about. First of all, you need to know how to identify that you're working with the 45, 45, 90 degree triangle. First, make sure you see the box in the corner. That tells us that it's a 90-degree angle. Next, make sure the remaining two angles are equal. Since there's 180 degrees in a triangle, and we know our box already used 90, if the last two angles are equal, that means they must be 90 and half or 45 apiece. Now we're going to get into the labeling. Those cursive lowercase l's mean the word leg. Those are the short sides of these triangles. In a 45, 45, 90 triangle, those two short sides are always equal. As you can see in this picture, they both just have a lowercase l, which means leg and leg. They're the same thing, or the same number. This just means that if you know one of the short side lengths, you automatically know the other one because they're always the same exact value. Here's a really quick example problem to show you how simple this really is. See how one of our legs is already labeled 5? Guess what the other leg is? It's also 5. Now here's just a reminder, in red I wrote the word leg and leg on both of the short sides. I also put those tiny little red tick marks in there which say the sides are congruent, and that's why we know both of them are 5. Now remember, back in the textbook it shows for our formula of 45, 45, 90 triangles, both of the legs are just lowercase l's. That means that they're the same length, and that's what we saw in our example problem. Now I want to focus on the hypotenuse. Remember, it's the longest side of the triangle, which is always straight across from the 90-degree angle in the corner. Remember, once we identify that little box, we just go straight across as if it's pointing to the hypotenuse. Little handy-dandy trick there. Now what I want you to focus on is see that all that is a little cursive L times the square root of 2. So that means whatever the leg length is, which we know both legs are the same, we just multiply that number times the square root of 2 and we know our hypotenuse. So let's go back to our problem from earlier. All we started with was knowing that one leg was the value 5. That meant the other leg had to be 5 as well. So now let's focus on the hypotenuse. What could that be? I don't want you to think too hard because it's actually simpler than you think. So here we go. I identified the box and the arrow pointing straight across to the hypotenuse, which I labeled in green. And below it, you can see I have leg times root 2. So the number 5 times root 2. And guess what? We're done. Something really important I want to point out is that we can always use Pythagorean theorem to figure out what a hypotenuse is when we know both of the legs. That means for the example problem that we've been working on, we would take 5 squared plus 5 squared equals hypotenuse squared. In this problem, I used an h to represent hypotenuse. And now we just solve algebraically. 5 squared is 25, plus 5 squared is another 25, equals h squared. And then we combine like terms, so we get 50 equals h squared. Then we need to take the square root of both sides because we had h squared, and we want to solve for h. So we reduce the radical of square root 50, and then we can factor it into 25 and 2, and then the 25 reduces to 5 and 5. So to finish simplifying the radical, we recognize that there's a pair of 5s there, so we're able to pull out a 5 outside of the radical, and then we have a remainder of 2 inside the radical, which leaves us with 5 square root 2 equals h, or equals the hypotenuse. And that is exactly what we got when we used our shortcut trick with special right triangles for 45, 45, 90 triangles. So like I said, Pythag is always going to work, but why not use the shortcut when you have a special case, just like 45, 45, 90s? Alright guys, now go ahead and try some practice problems to see how this goes. Things do get a little more complicated, but don't be scared like this guy, because you're going to be alright, and I'm going to have another video that shows a little more challenging of a problem. And I want to say good work, because you're already taking steps in the right direction by trying to get extra help, so kudos.